In this video, you will learn how to solve for different types of asymptotes. These include vertical asymptote, horizontal, and also slant asymptotes, also known as oblique. Let's start off with the equation y equals 1 over x minus 1. Let's find the vertical asymptote first. To find the vertical asymptote, you will have to set the denominator equal to 0. Now let's do the inverse on one side to let x be on one side. Let's add 1 on both sides. This will leave us with x equals 1. Now let's simply draw our vertical asymptote at x equals 1. Now moving on to finding the horizontal asymptote, we have to think about dominance and degrees. There is no variables on the numerator, but there is one on the denominator. There is an imaginary 1, which means that the denominator is dominant by 1. Whenever the denominator is dominant, y equals 0. Now let's draw our horizontal asymptotes at y equals 0. Now we're not done yet. We also have to find our x and y-intercepts to fully graph this function. To find x-intercept, let's set y equals 0. So 0 equals 1. We have to forget the denominator and only focus on the numerator. 0 does not equal 1. This means there is no x-intercepts. Now let's move on to the y-intercept. To figure out the y-intercept, we have to set x equal to 0. So let's simply do that. Y equals 1 over 0 minus 1. The denominator is negative 1, which turn into negative 1, and it will be 1 over negative 1. So simply our horizontal at our y-intercept would be 0, comma, negative 1. Let's label our x and y-intercepts now. Our x-intercept, which is none, and our y-intercept, which is at 0, comma, negative 1, will be right over here. Now that we have 1 point, we still can't fully graph. We have to figure out different points to be able to graph. So let's set an x and y chart and plug in different values. Since our vertical asymptote is at x equals 1, let's pick numbers to the left and to the right. This would be 0 and 2. When plugging in 0 and 2 into the equation, plugging in 0 would give us the output of negative 1. And plugging in 2 would give us the output of 1. These are our coordinate points now. We can label them. 0, comma, negative 1 is right over here, like we labeled last time. And also, 2, comma, 1 would be right over here. Now we could graph. Our final graph would look like this. Notice how our graph doesn't really touch the asymptotes. This is just really how asymptotes behave. Now let's move on to something a bit harder. Let's try the equation y equals 1 over x plus 2 squared. To the vertical asymptote, we would have to set the denominator equal to 0. So x plus 2 equals 0 squared. We have to do the inverse by square rooting both sides to get rid of the squared over here, and this would leave us with x plus 2 equals 0. Let's subtract the 2 by doing inverse, and this would give us x equals negative 2. Now let's simply graph our vertical asymptote at x equals negative 2. It would look like this. To do the horizontal asymptote, we would have to focus on dominance in degrees. And since there's a squared in the denominator and no variable at all in the numerator, the denominator is dominant. And just like our previous question, whenever the denominator is dominant, y always equals 0. So let's graph that. It would look like this. Now let's figure our x and y intercepts. for our x-intercept, we would have to plug in 0 into y and only focus on the numerator. And again, 0 does not equal 1, so there's no x-intercepts. Now for our y-intercept, we would have to plug 0 into x. But we also have to factor our denominator, and we could do that by using dots, difference of two squares. So x plus 2, x plus 2. And we could simply plug in 0 into our x's. And this would mean 0 plus 2 equals 2, and then 0 plus 2 equals 2. So it would be 1 over 4. And in coordinate notation, this would look like 0, comma 1 over 4. So let's label our y-intercepts. Our y-intercept would be right over here. Somewhere over here. Now we're not really finished because we also need more coordinates. And just like last time, let's create an x and y table. We have to, since our vertical asymptote is x equals -2, let's plug in values to the left of -2 and to the right. These would be -3 and -1. Plugging these into the equation would output 1 for -3 and also 1 for -1. And these are coordinates that we could use to help us graph. -3, comma 1 would be right over here. And then -1, comma 1 would be right over here. So now we could finally graph this equation. And it would look like this. Remember, we never touch our asymptotes. And there. Let's try something even more challenging. How about y equals 2 times x squared minus 9 over x squared minus 4. For a vertical asymptote, since we're only focusing on the denominator, we could factor out by using dots, difference of two squares. This would look like this. X minus 2, x plus 2 equals 0. We have to think about what plugged into x's would output 0. These numbers would be 2 and -2, which would mean our vertical asymptotes will be located at x equals 2 and x equals -2. And yes, there could be more than one asymptote for either horizontal or vertical. Now, let's draw those. At x equals -2 and x equals 2. Now moving on to our horizontal asymptote, we have to look at dominance in degrees. We could obviously see that they both have the same amount of squares, since it's x squared and x squared on the numerator and also on the denominator. And whenever you fall into a situation where you see both the denominator and the numerator having the same amount of exponents, then you basically divide by the first terms. There's a 2 in the numerator and a 1 in the denominator, an imaginary 1. This would simply give us 2 over 1, which would be y equals 2. Now we could draw that at y equals 2. Now let's move on to our x and y intercepts. For x-intercept, we have to make y turn into 0. So this look like 0 equals. And again, we only have to focus on the numerator. And we could first factor out using dots. So this would look like 2 times x plus 3 and x minus 3. And then again, we have to think about what plugged into x's would output 0. Plugging in negative 3 and 3 would result in 0 times 0 times 2, which simply equals 0. So our x-intercepts would be negative 3 comma 0 and 3 comma 0. We could label those now, and those would be located right over here and also right over here. Now moving on to our y-intercepts, we have to plug 0 into our x's. This would change the equation into 2, and also you don't have to factor when figuring out into y-intercepts. An easier way you could do is just plug in to your calculator and make input 0 into your x, and this would turn equation 2 times 0 squared minus 9 over 0 squared minus 4, which would equal negative 18 over negative 4. Simplified, this would be 9 over 2. So now our coordinate notation for our y-intercept would be 0 comma 9 over 2. Let's label that. That would be located right over here. And now we could finally graph. Our finished result would look like this. Again, never touching our asymptotes. And also for this one, like the previous ones, we don't have to do finding any other coordinates, since this is all the information we really need, and we can graph it. And our final result would look like this. Now let's try our final problem. Y equals x squared minus 2x plus 4 all over x minus 1. Let's find our vertical asymptote first. To find the vertical asymptote, again, you would have to set the denominator equal to 0. X minus 1 equals 0. This would give us x equals 1, just like our previous couple questions. Now we just label that at x equals 1. And then for our horizontal asymptote, we would have to look at degrees. Here is the thing though. Whenever your denominator is greater in degree by 1, there is no horizontal asymptote. There is something we call slant asymptote or an oblique asymptote. Again, this only happens when your numerator is greater than by 1 than your denominator. So there is no horizontal asymptote. Let's try the slant asymptote. To figure out your slant asymptote, we will try synthetic division. And this is only applicable when your denominator has a degree of 1, not a degree of 2, 3, 4, etc. It only has to be 1. This would look like this. We put our first term, which is x squared. There's an imaginary 1 in the middle, in the beginning, right over here. Then we put this, this 1 comes from your denominator. Since it's a negative 1, you would do the opposite, which is 1, which would give us this 1. Then you focus on the numerator and you look at the first terms. We have a 1 in the beginning, then a negative 2, and then a 4. Now we would have to drop our first term. This would give us 1, and we multiply this by our beginning term, and we input it over here, which would give us 1, since 1 times 1 equals 1. Again, and then our next step would be having to add this. That equals negative 1, and then multiply. And then 1 times a negative 1 gives you negative 1, and then you add, just like we did right here, and this would give us 3. Now we have to format this into an equation, which we could make into our slant asymptote. Y equals, you would only have to focus on these first two. Leave this out. This would give us 1x minus 1. Our first term will turn into a variable, and we will leave our second term into how it is. And then this is our equation for our slant asymptote. Let's label that. This is a y equals mx plus b type format. Our y-intercept for this equation would be negative 1, as it's our value for b. And our slope is 1, so we would just go up 1 and to the right 1, and it would look like this. Now for x-intercepts, we have to focus on the numerator and plug 0 into y. So 0 equals x squared minus 2x plus 4. Subtract the 4. Negative 4 equals x squared minus 2x. And from here on, this equation doesn't really make sense, because you could divide the negative 2 and you could square root, and it will give you something that doesn't really make sense and doesn't equal. So from that, we could assume that there is no x-intercepts. And then moving on to our y-intercepts, we plug in 0 into our x's. So y equals 0 squared minus 2 times 0 plus 4 over 0 minus 1. 0 squared is 0, negative 2 times 0 is 0, so it would be 4 over negative 1. And in coordinate notation, this would be 0 comma 4 over negative 1. And this is also basically just 0 comma negative 4. And this would, our y-intercept would be located right over here. Now we could finally graph our equation, and we don't really need any additional information. So our final graph would look like this. We pass through that y-intercepts and don't touch the asymptotes. And same for this one, don't touch the asymptotes. And finally, you figure out our vertical asymptotes, horizontal asymptotes, and also slant asymptotes. Thank you for watching.